All the way off. Hey guys, we're going to do a measures of variations video, but this time we're going to use salt. There is a video on there with the TI-84 and another one where I actually wrote out some information about the test scores of behavioral statistics class grades. I do want to go over using salt because it does come free with your WebAssign subscription. Anyway, let me get to it. Kevlar epoxy is a material used on the NASA space shuttles. Strands of this epoxy were tested at the 90% breaking strength. The following data represents time to failure in hours for a random sample of 50 epoxy strands. Now, with a large data set like this, you're going to want to use the salt instead of a TI-84 unless you're willing to carefully type out all 50 of these values. Let X be a random variable representing time to failure in hours at 90% breaking strength. Okay, now when I click on use salt, it's going to populate that program with all the data. I do need to go to descriptive stats, and for this section, you're also going to want to go over here to the left and check sum and sum of squares, because on the very last problem in your homework, you're going to be asked for those. Okay, now I'm going to bounce back and forth, so I'm going to try not to do it just too fast. But I'm going to go back here. First thing we're doing is finding the range. Range is maximum value minus minimum value. 7.89 minus 0.02, I get 7.87. And that matches your answer key. The next two items are sigma x and sigma x squared. That's the sum of the values and the sum of the values squared. That's why I recommended you checking these two boxes over here. Sum is 62.12. Sum of scores is 164.3358. So mentally keep these in your mind. Those are the two values for the next two boxes. Now on part C, we're asked to find mean, variance, and standard deviation. Variance is standard deviation squared. Or another way to look at it, standard deviation is variance square rooted. The mean is given here, 1.2424. Standard deviation, 1.3337. If you type that into your calculator and square it, or multiply the number times itself, that answer will be your variance. 1.3337 squared is 1.778. Okay, so the mean, 1.2424. The standard deviation was 1.337. Square that, and you get the variance. Coefficient of variation. S divided by X bar. 1.3337 divided by 1.2424. Part D wants it as a percent, so times 100 is 107%. The standard deviation of the time to failure is a little bit larger than the average time, and that makes sense. Standard deviation was a little bit more than the mean. A small coefficient of variation, you can look at it two ways. Either the standard deviation is smaller or the average is larger. But because both of these answers are based on the value of standard deviation, you would use the top choice. because standard deviation is smaller. Because and think of it this way too, if you can decrease your numerator, you make your fractions value smaller overall. Hope this helps.